If you want to see how a single workshop in California quietly rewrote the rules of high-performance off-roading, stay with this until the end. Subscribe to join the ongoing investigation into machines that hide radical engineering behind familiar shapes. Joe Scarbo grew up where the California desert meets the edge of possibility. Before the world knew his name, he was wrenching on off-road trucks in a modest garage, chasing the unforgiving terrain of Baja and the World Off-Road Championship circuit. In those races, survival depended on more than horsepower. It demanded a sixth sense for what breaks, what bends, and what can be fixed in the field. Joe carried that mindset into Scarbo Vintage, the workshop he founded in 2009 in Southern California. The shop's walls are lined with the tools and trophies of a career spent turning race failures into engineering lessons. Scarbo's team does not look like the boardroom armies of major automakers. Instead, a handful of fabricators and machinists work alongside Joe, blending old-school craftsmanship with digital modeling and CNC machines. Here, the past is never just a style reference. It is a proving ground for ideas that most manufacturers will not risk. The SV Rover began as a question. What if the boxy, iconic silhouette of the Defender could hide a machine built for the brutal demands of desert racing? What if nostalgia could be a disguise for something that rewrites every rule? The answer took shape not in a corporate studio, but in a shop where every weld and carbon layup was tested against Joe's memories of broken parts and midnight repairs. The SV Rover's familiar outline is a deliberate illusion. Underneath every joint, every tube, every bolt is there because it survived the desert first. This is not a tribute to the past. It is an argument with it staged by a builder who never accepted that limits were set in stone. On paper, the Scarbo SV Rover reads like a dare. The headline claim, 1,500 horsepower from a mid-mounted twin-turbo V8 running on E85, pushes far beyond anything offered by a mainstream off-roader. That number alone would be enough to raise eyebrows, but it is only the beginning. The chassis is not a ladder frame or a modified production shell. Instead, it is a full tube frame structure, engineered from scratch to handle stress levels more common in trophy trucks than in street vehicles. The suspension is not just heavy-duty, it is pushrod actuated, a design borrowed from top-tier race cars, giving the Rover up to 30 inches of wheel travel. Where a classic Defender wears fixed steel fenders, the SV Rover features active fenders that pivot out of the way during extreme articulation, controlled by sensors and electric actuators. Every major load-bearing part, control arms, pivot cups, even the bell cranks, are machined from solid billet aluminum or chromoly steel with tolerances measured in hundredths of a millimeter. These are not off-the-shelf parts. They are designed for rapid replacement, even in the field. Scarbo's marketing does not shy away from superlatives. The SV Rover is presented as the world's first street-legal Hypertruck, a claim that carries its own weight given California's strict emissions and safety rules. The promise is clear, a vehicle that looks like a Defender but delivers the performance envelope of a hypercar with the serviceability of a desert race truck. For a small shop, these are bold statements, each one demanding proof. The specs on the table invite skepticism and set the stage for a deeper investigation into whether a handful of engineers can really outpace the caution and inertia of global automakers. Scarbo Vintage's workshop is a study in precision, where the SV Rover's foundation is built from racks of 4,130 chromoly tubing. Each tube is cut, mitered, and TIG welded by fabricators who treat every joint as a test of skill. Weld seams are stress-relieved in a post-weld heat cycle echoing aerospace routines. This is not mass production, but a deliberate process where every bead and bracket is shaped by experience earned in off-road racing. Carbon fiber panels begin as sheets of pre-preg, already saturated with high-temperature epoxy. Technicians trim and stack the fibers, laying them into custom molds before sealing them in a programmable autoclave. Inside, pressure and heat climb to 180 degrees Celsius, curing the resin into a monocoque shell that is both light and rigid. The process leaves no room for error. A single flaw can weaken an entire panel. The result is a body shell that weighs far less than steel, yet delivers the stiffness demanded by competition. Billet aluminum and chromoly blocks are transformed on a 5-axis CNC mill, which carves out control arms, bell cranks, and pivot cups to tolerances within hundredths of a millimeter. The lead machinist inspects each part with digital calipers, searching for the smallest deviation. These components are built for rapid repairs and modular upgrades, every mounting point and bracket designed for purpose, not show. Beneath the familiar Defender silhouette, the SV Rover's chassis and body are products of relentless focus on strength, serviceability, and weight. The tools, autoclave, chromoly rig, CNC, are the quiet force behind its promise. A test driver straps in, the twin-turbo V8 idling behind the cab, sensors armed, and data loggers ready. The first run is all about numbers, not impressions. Linear Variable Displacement Transducers, LVDTS, track every millimeter of wheel movement. On a calibrated ramp, the suspension cycles from full droop to full compression. The digital trace reads out 30.2 inches, verified from hub center to bump stop. No production SUV, not even a Baja pre-runner, comes close. The real trick isn't just the raw travel, it's what happens above the wheels. As the chassis flexes, active fenders pivot outward, their motion tracked by actuator logs. Each fender swings up to 45 degrees, triggered by a travel limit potentiometer on the push rod. The log shows smooth, repeatable cycles, no stalls or over travel. Fail-safe logic kicks in if power drops, defaulting to open so nothing binds even in a worst-case scenario. Thermal validation comes next. With the engine held at sustained load, a thermal camera scans the bay. Temperatures stay within the prescribed envelope. Coolant peaks at 102 degrees Celsius, turbo housings stay below 160 degrees Celsius, and the carbon firewall remains cool enough to touch. The numbers confirm that the cooling package isn't just theoretical, it holds up under real-world abuse. On the trail, GPS telemetry records a 0 to 60 sprint in under 3.8 seconds, then maps a full throttle run across a dry lake bed. Lateral G spikes and altitude data log every bounce and landing. The data isn't just for show, it's the measured proof that a carbon-bodied machine built in a small California shop can back up every wild claim with evidence. The familiar Defender shape on this day becomes the shell for a set of numbers that most automakers would never dare to chase. A price tag of $1.5 million draws a line in the sand. That number is not just about exclusivity, it is a direct result of the way the SV Rover is built. Every carbon fiber panel starts as raw pre-preg, hand-trimmed and stacked by technicians, then sealed for hours in a programmable autoclave. The labor alone, skilled, repetitive, unforgiving, would bankrupt a mass-market project. Then there is the billet. Control arms, bell cranks, and pivot cups carved from solid blocks of aluminum or chromoly, each part taking hours on a 5-axis CNC mill. No shortcuts, no stamped steel, no off-the-shelf solutions. The result is a vehicle assembled in single digits, not hundreds. Each one is a custom order, shaped by the realities of small batch manufacturing and the uncompromising standards of a racing workshop. The $1.5 million cost is not just for performance, it is the price of breaking away from industrial routine. Scarbo Vintage calls the SV Rover street legal, but the paper trail tells a more complicated story. A search of California's Department of Motor Vehicles database turns up no vehicle identification number assigned to Scarbo or the SV Rover, no record of a title, no trace of a manufacturer's emissions exemption. The California Air Resources Board, CARB, keeps a public list of vehicles with approved emissions systems. As of spring 2026, there is no entry for a Scarbo-branded Hypertruck, no executive order for a twin-turbo V8 running E85. This does not mean the vehicle cannot be registered. Boutique builders sometimes navigate the system as special construction or under low-volume exemptions, but these routes come with risk. Without a published compliance certificate, every claim of legality rides on trust, not documentation. For a workshop like Scarbo Vintage, the calculation is different than for a major automaker. They are willing to accept uncertainty to push boundaries that big brands will not touch. The result is a vehicle that dares regulators to catch up, leaving the burden of proof hanging in the air. Today, engineering revolutions often hide behind familiar faces. As big manufacturers hesitate, small teams like Scarbo Vintage redefine what is possible, proving that radical ideas can outpace nostalgia and regulation. The next breakthrough may look ordinary, but its impact will rewrite the rules all over again. What do you think?